In this video, we're going to look at an introduction to some of the characteristics of rational functions. So the first question is, what is a rational function? Okay, so I want you to just take a look here. Here we have the addition of two polynomials, subtraction of two polynomials, multiplication of two polynomials, and division of two polynomials. And I just want you to simplify them, pause the video, take a minute, and decide, are they polynomial or are they rational? Okay, so there's just some simplification of all of them. And let's take a look at A first. Simplified there, added together, got x squared plus 9x minus 11. Obviously, that's quadratic. Therefore, that's a polynomial function, right? Okay, similarly in B, the subtraction there, you can see that that's a degree 3 polynomial function with a negative leading coefficient. Again, obviously then a polynomial function. C required a little bit more work, but you can see again that we have a cubic polynomial function. Okay, and D, there's not much you can do to that other than I'm just reminding you that this is what it means, x minus 2 over x squared minus 6x plus 2, and hopefully it makes sense to you that this is in fact a rational function. Okay, so just in terms of a conclusion here, I hope it makes sense to you that you can see that when we add, subtract, or multiply polynomial functions, we get polynomial functions. But when we divide two polynomial functions, we get what is called a rational function. So let's just take a minute and write that in. So that's the idea, and that leads us to our definition of a rational function. So a rational function has the form h of x equals f of x over g of x, where both f of x and g of x are polynomial functions. Now, one thing, of course, that we are going to have to consider is those restrictions that we didn't pay too much attention to before, and that is the fact that g of x cannot equal 0, right, in the denominator. Otherwise, this function would be undefined. Okay, so we're going to start our look at rational functions by just looking at the basic reciprocal function. And hopefully you do recall learning about the graph of 1 over x from grade 11. You should have seen that briefly in grade 11, but we're just going to review a few of the characteristics and talk about a few new ones as well, okay? Just one note, when you're looking at these graphs, of course, when they are snipped from Desmos, they do have arrows, right, that suggest that they continue on. So just make sure that you have that. Okay, so do yourself a favor, pause the video, and see if you can at least take a look at the domain, the range, x-intercept, y-intercept. When is it positive? When is it negative? Any symmetry, and any maximums or minimums. Okay, take a guess, do it in pencil, pause the video, and see what you think. Okay, so hopefully you can see that the domain is all real numbers except for x cannot equal 0. So we would write that like this. All real numbers except. Okay, and same with the range. You'll notice y cannot equal 0. All real numbers other than that. Okay, you will notice that there is no x-intercept and no y-intercept. Okay, in terms of local maximums or turning points, there are none. And there's actually no absolute maximum or minimum in this case as well, so there are none there. Now, in terms of symmetry, remember, we don't focus on that too much, but if you took this graph, let's say the right-hand side, and rotated it around the origin 180 degrees, you could actually see that it does have, in fact, point symmetry. Okay, so this is an example of point symmetry. Okay, now let's take a look at those end behavior statements together, something that's new and very important in grade 12. Okay, so similar, we can't use the quadrant notation here with rational functions. One of the reasons that we need to be comfortable with this notation, so as x approaches infinity, take a look here, as x continues on towards infinity, what's happening to the value of the function? And hopefully you can see that the value of the function f of x is approaching 0. Okay, and that's same thing is true here as we approach negative infinity. This graph is getting closer and closer and closer to a y value of 0. So we would say as x approaches negative infinity, f of x also approaches 0. Okay, and those are our end behavior statements there. Let's look at the intervals that are positive. Intervals of positive is greater than 0, so above the x-axis. So we would say here when x is greater than 0, okay, or from 0 to infinity. And hopefully you can see then that it is negative in this section right here. Okay, so it is negative when x is less than 0 or from negative infinity to 0. Okay, so I do want to add 2 new characteristics that are unique or special for rational functions. And the first one is what we call the horizontal asymptote. And we will call that HA for short. Okay, and hopefully you can see that there's this imaginary line that the function looks like it's approaching in the extremes, and the equation of that line would be y equals 0. Okay, similarly, we have another one right here. You can hopefully guess that this one is called a vertical asymptote. Or VA for short. And hopefully you can see that the equation of that vertical line is x equals 0. Okay, so what we're going to do now, that's the basic rational function. And what we're going to do now is we're going to look at some more complicated ones, and we're going to identify all of these key characteristics as well. Okay, so you're going to use Desmos to help you out with this. So you're going to go to student.desmos.com, and you're going to log in with your Google account. And you're going to put in this activity code. And this activity code, it just has the graphs already there for you so that you don't have to type them out. So this first equation right here would be written in Desmos. And you're going to go ahead and you're going to use that graph to state the equations of the vertical asymptotes, the equations of the horizontal asymptotes, the x-intercepts, y-intercepts, and the domain. Those are the 5 characteristics that we are going to focus on. And then you're going to draw a rough sketch at the side. And I just want to show you that I do want you to draw this sketch using a ruler and a little bit accurately, as you're going to need to pay attention to those asymptotes. So for the first one, when you go into Desmos, I don't have a ruler tool in this, but you will use a ruler. Try your best. Okay, you will want to just pay attention to labeling and making it sort of as accurate as possible here. Okay, so when we take a look at the first one, you can go ahead and punch it in. I just want to emphasize what that would look like here. We end up having a vertical asymptote. We end up having a horizontal asymptote, and you're going to want those to be clear in your sketch. Okay, and then we end up having a y-intercept and an x-intercept. Okay, so this is basically what your first one should look like in terms of how accurate we need to be in that. Okay, so you're gonna complete the next 5, and then you're gonna come to some conclusions, and we're gonna learn a little bit more about this. Okay, so go ahead on to Desmos now.